So here I have a problem that's technically classified as a differential equation, but you really only need an understanding of basic derivative calculus to solve it. It asks us to find the functions that satisfy the 2022nd derivative of f is equal to 2 to the power of 2022 times f of x. So the first looping functions that come to mind for me are the sine and cosine functions. So I'm just writing this as a sine x and b cosine x, just as an arbitrary constant out front, because those don't really change the derivatives at all. And the fourth derivative of these, so f4 prime of x is equal to f of x in this case, because when you take the fourth derivative of sine, you get sine back, and when you take the fourth derivative of cosine, you get cosine back. And same with negative sine and negative cosine, but that's encompassed by these two constants a and b here. So that's one looping function that we have, but we also have the functions that loop only once. So f of x equals a times e to the x. When you take the derivative of this thing once, you get back f of x. That's because when you take the derivative of e to the x, you just get e to the x back. And then there's one more function group that when you take the derivative twice, you get the similar function back, that being f of x equals e to the minus x. When you take the derivative of e to the minus x once, you get minus a times e to the negative x, but when you take it twice, you get back positive a times e to the minus x. So f2 prime of x here is equal to f of x. And these are the only looping functions that I know of from Calculus 1, or derivative calculus. So let's go ahead and apply these and see which ones fit our f 2022 prime of x is equal to 2 to the 2022 power times f of x. So first we need to know whether 2022 is divisible by 4. And we can pretty quickly see that it's not, because 2000 is divisible by 4 and 20 is divisible by 4. But that means that 2022 is not. So that cancels out this entire section of functions up here. We're not going to be using sine and cosine. We're definitely going to be having some kind of e to the x values here, because those only need 1 to repeat. And because 2022 is even, we'll also have a part of the function being e to the minus x. So let's get rid of all of this over here on the right, and then we'll jump into our solution. So in the last board, we didn't exactly prove, but we kind of inferred that this is the only function that could satisfy our condition over here, because we know that 2022 is not divisible by 4, so we don't need any sine or cosine function that loop every 4 derivatives, but we only need e to the x and e to the minus x, which loop every 1 and 2 derivatives. So I've combined those into one function up here where this alpha can be either positive or negative. So let's take one derivative of this f of x function and see what we get back. Here we would get a times alpha times e to the alpha x. And then if we took the second derivative, we would get a times alpha squared times e to the alpha x, and so on and so forth, where every time we took a derivative, we would also get an extra copy of alpha out here. But out here, we want to take the 2022nd derivative, and we want a 2 to the 2022 outside of our f of x function, where our f of x function can just be grouped as a times e to the alpha x, as us up here. But that means our alpha is going to be 2, because we're going to end up with a 2 to the 2022 power out here. So f 2022 prime of x is equal to alpha to the 2022 times a e to the alpha x. But now this satisfies exactly what we're looking for here, where alpha is equal to 2. However, there's one more solution that I've kind of overlooked so far, and that is alpha being negative 2. Negative 2 also works because, like I said before, we can use positive or negative value for this value of alpha up here based on the last board. And negative 2 to the 2022 power is the same thing as positive 2 to the 2022 power, because this power, this exponent, is even, meaning that we're going to output a positive number in both cases. So our final answer here is the family of functions f of x equals a, where a can be any constant whatsoever, e to the alpha x, where alpha is either 2 or -2. And that's enough for now.